the last video, I have discussed the basic formulation of transportation models. Today, I am going to discuss how to solve transportation problems. To solve transportation problem, we first find initial basic feasible solution, and after that, we find optimal basic feasible solution. I represent initial basic feasible solution by IBFS and optimal basic feasible solution by OBFS. To find initial basic feasible solution, we have the following three methods. First is northwest corner method. I represent northwest corner method by NWCM. And second is least cost method. I represent least cost method by LCM. And the third is Bogle's approximation method. I represent Bogle's approximation method by VAM. Before discussion of initial BFS methods, first I am going to discuss how to change unbalanced transportation problem into balanced transportation problem. Because initial BFS methods and optimal BFS methods are applicable to balanced transportation problem. Therefore, if we have given unbalanced transportation problem, before going to initial BFS methods, first we change unbalanced transportation problem to balanced transportation problem. I discuss how to change unbalanced transportation problem into balanced transportation problem with the following example. Consider the transportation problem as here S1, S2, S3 represents the source, D1, D2, D3, D4 represents the destinations. Here these numbers are represents the cost of unit transportation from different sources to different destination. Like 5 is represent the unit cost of transportation from source S1 to destination D1, and 2 represents the unit cost of transportation from source S1 to destination D2. Other are the discussed in similar manner. These are the availabilities at the different sources. 30 availability at source S1, 20 availability at source S2, 40 availability at source S3. These are the demands at different destinations. 10 demand at destination D1, 10 demand at destination D2, 40 demand at destination D3, 50 demand at destination D4. Firstly, we will check that the whether problem is balanced transportation problem or is unbalanced transportation problem. In the last video, I have discussed that the balanced transportation problem is that one in which total availability is equal to total demand. Here we will check total availability is 30 plus 20 plus 40, that is 90. And the total demand is 10 plus 10 plus 40 plus 50, that is 110. Total availability is not equal to total demand. Therefore, problem is unbalanced transportation problem. As total availability is not equal to total demand, that is 90 not equal to 110, therefore our transportation problem is unbalanced transportation problem. Now I am going to discuss how to change unbalanced transportation problem to balanced transportation problem. For this, create a dummy row or dummy source. If total demand exceeds total supply, or we call total availability, and create a dummy column or dummy destination if total supply exceeds total demand. The supply or demand at the dummy origin. From dummy origin we means dummy source or dummy destination. is equal to symmetric difference of total supply and total demand. From symmetric difference we means we ignore the sign. We only take differences and ignores the sign of that difference. Now, as our problem is unbalanced transportation problem, because here total availability is not equal to total demand. Now, as total demand exceeds total supply, as total demand exceeds total supply, look at here, if total demand exceeds total supply, we create a dummy room. Now we change this problem into balanced transportation problem, as here we create a dummy row, or we say dummy source S4 with the cost as 0, 0, 0, 0. Now this is our demand, which is given as 10, 10, 40 and 50. Now what is the availability at this source? Availability at this source is the symmetric difference of total supply and total demand. Our total demand is 1110, total supply is 90. The symmetric difference of total demand and total supply metric difference is 20. 1110 minus 90, metric difference is 20. Therefore, the availability at this dummy source is 20. Now we will check. Total availability is 30 plus 20 plus 40 plus 20, that is 1110, and total demand is 10 plus 10 plus 40 plus 50, again 1110, as total availability. Now total availability is equal to total demand. Therefore this problem now changed into balanced transportation problem. That is how we change unbalanced transportation problem to balanced transportation problem. Now take another example. Consider the transportation problem this. Now this is again an unbalanced transportation problem, as total supply 7 plus 13 plus 50 equal to 70, and total demand 10 plus 20 plus 30 equal to 60. As total demand is not equal to total supply, therefore it is unbalanced transportation problem. Now we will discuss how we change this unbalanced transportation problem into balanced transportation problem. In this case, total supply is greater than total demand, that is 70 is greater than 60. Now look at this. If total supply exceeds total demand, then we have to create a dummy column or dummy destination. Now we will create a dummy column or dummy destination as this is dummy destination D4. The cost is 0, 0, 0. Supply as given 7, 13, 50. Now, what is the demand at this dummy destination or dummy column? That is the symmetric difference of total supply and total demand. As total supply is 70 and total demand is 60, symmetric difference is symmetric difference is 10. Therefore, we will take the demand of this dummy destination as 10. Now we will check total supply is 7 plus 13 plus 50, that is 70. Total demand is 10 plus 20 plus 30 plus 10, that is 70. Now, as total availability or total supply is equal to total demand, therefore this becomes the balanced transportation problem. This is the cases that how we change unbalanced transportation problem to balanced transportation problem. If total demand exceeds total supply or total availability, then we create a dummy row, and if total supply exceeds total demand, then we create a dummy column or dummy destination. And the supply or demand at the dummy origin, that is dummy source or dummy destination, is equal to the symmetric difference of total supply and total demand. Now I am going to discuss initial Bfs solution method, northwest corner method. I am going to discuss NWCM with the help of an example. Consider the following transportation problem. Here S1, S2, S3, three sources, D1, D2, D3, D4 are four destinations. These numbers represent the unit cost of transportation from different sources to different destinations. Like 4 represents the unit cost of transportation from source S1 to destination D3. These are the supply givens at the different sources. 30 is the supply at source S1, 40 is supply at source S2, 55 is supply at source S3. And these are the different demands given at different destinations. Now, firstly, we will check whether the problem is unbalanced or problem is balanced. Here, the total supply is 30 plus 40, 70, 70 plus 55, that is 125. And then here total demand is 50 plus 40 plus 20 plus 15, that is 125. As total supply is equal to total demand, therefore this is balanced transportation problem, and we will continue with the northwest corner method. Now we will discuss how northwest corner method works. In this method, we have to allocate in different cells like this. Firstly, you have to choose according to the name northwest corner. This is the northwest corner. We made first allocation here in this cell. Look at this. Corresponding to this column, here demand is 15, and corresponding to this row, here supply is 30. You have to take minimum of this supply and this demand, that is minimum of 15 and 30. The minimum of 15 and 30 is 15. Therefore, we first allocate 15 here. Now, as here at destination D1 to demand is 15, and here at source S1 supply is 30, we here allocate 15 units. Then after allocation of 15 units at this cell, the remaining supply at source S1 is difference of these two. Difference of these two is 15. The remaining supply at source S1 is 15. Now, as the demand of this column is fulfilled, because the demand is 15 and 15 we here allocate, therefore we cancel out this column. Cancel out this column very lightly. Now the remaining is this matrix. Remaining is this matrix. Now we allocate again in the northwest corner of this matrix. Northwest corner of this matrix is this cell. Now we continue in the similar manner that supply corresponding to this row is 15 and demand at D2 in this column is 20, and the minimum of 15 and 20 is 15. We allocate here in this cell minimum of 15 and 20. That is, minimum of 15 and 20 is 15. Therefore, we allocate here 15. And the demand after the allocation of 15 units remaining 5. That is difference of 15 and 20. That is 5. Now, as the supply is over in the source S1, therefore we cancel out this row. Cancel out this row with the dotted lines. Now remaining matrix is, this is our remaining matrix. Now again we will choose the northwest corner. The northwest corner is this cell. Now we will allocate in this cell. The demand corresponding to this column is 5 and supply corresponding to this row is 40. We will allocate here the minimum of 5 and 40. Minimum of 5 and 40 is 5. Minimum of 5 and 40 is 5. Therefore, we allocate here 5. After the allocation of 5, here demand is 5 and minimum is 5. We allocate 5. Therefore, the remaining supply at source S2 is the minimum of these two. Difference of these two is 35. Therefore, supply remaining at source S2 is 35. As total demand is covered in destination D2, therefore we cancel out this column with the dotted lines. Now the remaining matrix is, this is the remaining matrix. Now we will again select the northwest corner. This is our northwest corner. Now we will allocate in this cell. Here supply is 35 and corresponding to this column demand is 40. The minimum of 35 and 40 is 35. Therefore we allocate 35 in this cell. Now here 35, here 40. The demand left behind at destination D3 is subtraction of these 40 and 35, that is 5. As total demand is, as supply at this source S2 is 35 and 35 we will allocate. Therefore, we will cross this row with dotted lines. Now the remaining matrices, this and this. Now we will again choose northwest corner. This is our northwest corner. Now we will allocate in this cell. Here the demand is 5 and supply is 55. The minimum of 5 and 55 is 5. Therefore, we will allocate here 5, as the demand at this destination is 5 and 5 we allocate. Therefore, we will cross this column with the dotted lines, and the remaining supply at source S3 is difference of 5 and 55, that is 50. Now this cell is left with 50 here and 50 here. Therefore, we will allocate 50 here and again cancel out this column or this row. Now the northwest, according to northwest corner method, all the allocations are filled. This is the optimal basic feasible solution, that allocation of 15 from source S1 to destination D1, allocation 15 from S1 to destination D2, allocation 5 from source S2 to destination D2, allocation of 35 from source S2 to destination D3, allocation of 5 from source S3 to destination D3, and allocation of 50 from source S3 to destination D4. This is our optimal, this is our initial basic feasible solution. The initial basic feasible solution is given by multiply allocation with the cost S1 to D1, 15 into 5, S1 to D2, 15 into 2, S2 to D2, 5 into 4, S2 to D3, 35 into 9, S3 to D3, 5 into 8, S3 to D4, 50 into 1. After adding this, you will get your answer. After the calculation of this, we will get the initial Bfs solution, that is 830. Now I am going to discuss second method, that is least cost method. Consider the transportation problem as considered in northwest corner method. The transportation problem we considered is same. Here this transportation problem is balanced transportation problem, as total supply is equal to total demand. Now the allocation procedure in all the three methods is same, but cell selection in all the three methods is in different way. As in northwest corner method, we select cell always as northwest corner. Now as the least cost method, name least cost is self-explanatory. We will choose least cost from the matrix, as the least cost from all the entries is here 1. Therefore we will make first allocation in this cell. Allocation procedure is same as I discussed in northwest corner method. The demand corresponding to this cell is 50 and the supply corresponding to this cell is 55. Took the minimum of 50 and 55. Minimum of 50 and 55 is 50. Therefore we allocate 50, as demand is satisfied for this destination. Therefore we cross this column with dotted lines, and the supply remaining at source S3 is difference of these two, that is 5. Now the remaining matrix is this one. Now we will choose the least cost in this matrix. The least cost in this matrix is 2, which is at this cell and also at this cell. Now as tie in this case, you will take that where we have to allocate minimum. For example, if we take this cell, we will allocate minimum of 5 and 15, that is 5. If we took this cell, then we will allocate minimum of 20 and 30, that is 20. Therefore where you have to allocate minimum, you will took that cell as minimum. We will allocate minimum here. Therefore in the case of tie of these two cells, we will choose this cell. Therefore allocation procedure is same. Here supply is 5 and demand is 15. We will allocate the minimum of these two, that is 5, as supply here is over. Therefore, we will cross it with dotted lines, and the demand left at destination D1 is difference of these two, that is 10. Now this is the remaining matrix. Now we will choose the least cost in this matrix. Least cost is this. In this cell we will allocate in this cell. Here demand is 20 and supply is 30. The minimum of 20 and 30 is 20. We will allocate here 20, as demand at this destination is complete. Therefore we will cross this destination with the dotted lines, and the remaining supply at source S1 is difference of these two, that is 10. Now the remaining matrix is this and this, these four cells. Now we will choose the least cost in these four cells. Least cost is 4. Therefore, we will allocate now in this cell. Here supply is 10 and demand is 40. We will allocate minimum of these. Minimum is 10. Therefore, we will allocate 10 here, as the supply at source S1 is complete. Therefore, we will cross this row with dotted lines, and the demand left at destination D3 is difference of these two, that is difference of 40 and 10. Difference of 40 and 10 is 30. Therefore, demand left at destination D3 is 30. Now we left with these two cells. The least cost from these two cells is this. Therefore, we will now allocate at this cell. The demand corresponding to this cell is 10 and supply corresponding to this cell is 40. We will allocate the minimum of these two. The minimum of these two is, that is, the minimum of 10 and 40 is 10. Therefore, we will allocate 10 here, as demand is complete. Therefore, we will cross this with the dotted lines, and the supply left behind at source S2 is 30. Difference of 40 and 10. Now we will left with only one cell. Now we will allocate in this cell. At the last, the supply and demand corresponding to last cell is same. 30 here, 30 here. We will allocate 30 here. We will get from both sides, and you will get either along the column or along the row. This is the initial BFS by least cost method. Now initial BFS solution is given by, initial basic feasible solution is S1 to D2 20 into 2, S1 to D3 10 into 4, S2 to D1 10 into 6, S2 to D3 30 into 9, S3 to D1 5 into 2, S3 to D4 50 into 1. After the calculation, we will get the initial basic feasible solution as 470. Now I am going to discuss Vogel's approximation method. Consider the same transportation problem as considered in the first two methods. This is balanced transportation problem, as total supply is equal to total demand. The allocation procedure in all the three methods is same, but the cell selection in all the three methods is different. Like in northwest corner method, you have to always select northwest corner cell, and in least cost method, you have to select the cell in which least cost occur from all the entries. In Vogel's approximation method, we will select cell with the help of penalties. First, we will calculate penalty. To calculate penalty, take first row, choose its smallest entry, and subtract this from the entry higher, next higher to the smallest entry. I repeat, take the first row, choose its smallest entry and subtract this entry from the entry next higher to the smallest entry. Therefore, penalty this row is 1. In the similar manner, we will take second row. The smallest entry is 4 and subtract this entry from the next higher to the smaller entry, that is subtract from 4 from 5. Again we calculate penalty 1. Then we calculate penalty in this manner. Here smallest entry is 1 and the next higher entry to this smallest entry is 2. The penalty is again 1. Now we will calculate penalty column wise. We take first column, we take smallest entry, that is 2. Next higher entry to this smallest entry is 5. We will take the difference of these two, that is 3. Now we will calculate the remaining penalties. Here smallest entry is 4 and the next higher to this smallest entry is 3. The penalty is 1. Here penalty is 4. Smallest entry is 4 and the next higher entry to this smallest entry is 8 and the penalty is difference of 8 and 4, that is 4. In similar manner we calculate penalty for this column, that is 2. After calculating the penalties row wise or column wise, we will take the highest penalty. Highest penalty from row wise penalties and column wise penalty is 4. We will select this column. From this column we will select that cell where smallest cost occurs. Here in this column smallest cost occurs at this, therefore we will select this cell. Now we will allocate in the similar manner. The demand corresponding to this cell is 40 and the supply corresponding to this cell is 30. We will allocate the minimum of these two, that is 30. Therefore we will allocate 30. As the supply is over in this source, therefore we will cross this row with the dotted lines and the remaining demand at destination D3 is minimum difference of these two. Difference of these two is 10. Therefore demand 10 left at destination D3. Now we will continue in this manner. In the similar manner we will next calculate penalties. Now we will again calculate the penalties. As this row is crossed, therefore penalty we will represent blank. The penalty for this row is the smallest cost is 4 and the next higher cost is 5. Difference of 4 and 5 is 1. Difference of 1 and 2 is 1. Now column wise, as this is crossed, difference of 4 and 6 and 2 is 4. Difference of 4 and 3 is 1. Difference of 9 and 8 is 1. Difference of 5 and 1 is 4. Now we will choose largest penalty. As largest penalty is 4. Here it is 4. Here it is 4. Therefore tie in choosing largest penalty. In this case you will look at both the columns. Here in this column smallest cost is 2 and in this column smallest cost is 1. Therefore we will choose this penalty. That is, in case of tie for largest penalty, choose the lowest cost cell in all tied rows and columns for allocation, like in this case. Therefore we will choose this cell. In this cell the allocation is made in the similar way. Here corresponding to this cell demand is 50, supply is 55, minimum of 50 and 55 is 50. Therefore we will allocate here 50 as demand is complete. Therefore we will cross this column, and the remaining supply at source S3 is difference of these two, that is 5. Now we will again calculate the penalties. Now we will calculate the penalties. Here the remaining entries are these. For this row, as this is crossed, therefore lowest cost is 4 and the next to this smallest cost is 6. The difference of 4 and 6 is 2, therefore penalty is 2. For this row, penalty is 2 and 3, that is difference of 2 and 3, 1. Then we calculate penalties column wise, as this is crossed and this is crossed. For this column penalty is blank, and for this column penalty is difference of 6 and 2, that is 4. For this column difference of 4 and 3, that is 1. For this column difference of 9 and 8, that is 1. We will choose now highest penalty about these row penalties, and these column penalties highest is 4, therefore we will choose this column. About from this column the lowest cost cell is this, therefore we will choose this cell. Now we will allocate in this cell. Here the demand is 15 and supply is 5, minimum of 5 and 15 is 5, therefore we will allocate 5 here. And as the supply is over in this source, therefore we will crossed it with the dotted lines, and the demand left and destination D1 is difference of these two, that is 5 of 15. The difference of 5 and 15 is 10. Now we will left with one row. Now we will left with one row. In Vogel's approximation method, when we will left with one row or one column, then we will apply least cost method. Now we don't calculate penalties. We will, as we will left with only one row, we will apply least cost method. Here in out of these three cells, least cost is 4. Therefore we will allocate here. To allocate here, we will choose in the similar manner. Here demand corresponding to this cell is 20 and supply corresponding to this cell is 40. The minimum of 20 and 40 is 20. Therefore we will allocate 20 here. As demand is over, we will cross this column, and the supply left behind at S2 is 20. Again, this is the least cost cell. Out of these two cells, we will allocate here. Here demand is 10 and supply is 20. Out of 10 and 20, minimum is 10. Therefore, we will allocate 10. As demand is over, therefore we will cross this column, and the supply left behind at S2 is 10. Now we will left only with one cell, and the demand and supply is same. Therefore, we will allocate 10. We will cut from both sides. Now either we will cut column or we will get row. This is the initial BFS obtained by Vogel's approximation method. Now initial BFS solution by Vogel approximation method is given by this: S1 to D3, S2 to D1, S2 to D2, S2 to D3, S3 to D1, S3 to D4. 30 into 4, 10 into 6, 20 into 4, 10 into 9, 5 into 2, 50 into 1. After calculation, we will get the answer 410. Now, if you are free to choose from these three methods, then you have to choose either least cost method or Vogel's approximation method. Why so? Because in both the methods, that is in LCM method or in BAM method, cost is associated in selecting the cell where we have to allocate. Whereas in northwest corner method, cost is not associated in choosing the cell where we have to allocate. Therefore, if you are free, you have to choose either LCM method or Vogel's approximation method to find the initial basic feasible solution. Moreover, with the three methods, NWCM, LCM, and when. We have find the initial BFS solution. Initial BFS solution by three methods are different, but after applying the optimal basic feasible solution method, we will get the same answer.
फ्रेंड्स, अगर हम आपको हमारा ये मेथड अच्छा लगा तो प्लीज़ हमारे इस चैनल को सब्सक्राइब कीजिए और ये जो वीडियो के नीचे बेल आइकॉन का बटन है उसे प्रेस कीजिए, जिससे आपको हमारी न्यू वीडियोस की नोटिफिकेशन मिलती रहेगी। थैंक यू फ्रेंड्स।